hard drives like this one have a bunch of components inside them that you can use for different maker projects. So let's open this one up and see what's inside it. This is a 2.5 inch drive. It's typically in a laptop. The bigger ones in desktop computers have basically the same components inside them, so everything I'm showing you here can also be done on those bigger ones. I just happen to have this drive as a friend and regular viewer of the channel donated a couple of them to me. Okay, so that bit's off. Warranty void if removed. Let's peel this sticker off as well. I feel like there must be something, another screw under here. Yeah, there's one there. It's not coming off easily. Is there a screw under there? There is, look. Yes, we're in. Okay. So, this is the main drum that spins. Inside here is a little brushless DC motor. And this arm here is called an actuator arm. The way this works is, at the end of this arm there's a coil of wire sandwiched between two strong neodymium magnets. And when you give that wire a voltage, it turns into a magnet itself and it moves the arm. Giving it a positive voltage will move it one direction, and a negative voltage will move it the other. Presumably those wires connect to these pins here, and we can figure out which pins they connect to using a multimeter. So let's try that now. So we're in continuity mode, so when these touch together we get a beep. Okay, I found it. Let's try and solder a couple of wires onto those pins. Tin these up a little bit. Right, so let's attach a couple of clips onto there and there. And we'll flip this over. Now, if we give that some voltage, let's see what happens. If we swap the battery round, it goes that way. So the voltage one way makes the arm go that way, and the voltage the other way makes it fly back. So that's pretty cool, I think. I don't know what that could be used for in a maker thing, but some kind of robotic arm or something. Definitely has a use. Sort of gets a bit stuck one way, but Going back this way, it seems to get a bit stuck. I think that might be because of these reed heads. But anyway, so that's how the actuator bit works. Okay, so then of course in here, as I say, there's magnets. So it might be that you don't want to use the arm for anything, the armature for anything, but or the actuator, I should say, for anything, but you can also just open it up and use the magnets directly. These have got, see that there is it's a neodymium magnet. They use neodymium magnets because they're like really strong for their size. And then that's the coil of wire that we've just connected to. So when the electricity runs through that becomes an electromagnet, and it moves against these two magnets. So yeah, if you just want some really decent magnets, those are some pretty damn strong. And I believe one side of this is north and the other side is south, so that's the way the flux runs in these. So that's pretty cool. So those are useful. Right, now let's look at this. Inside here is a 3-phase brushless DC motor. So that means when it spins, we get 3 different AC currents. And those currents come out on the pins here. These are usually connected in what's called a Y configuration. Looks like this. And we can figure out which 3 we're interested in. We're interested in 3 of them, and one of them we can just ignore. So if we look at the resistance between the different pins, the resistance between those pins, okay, it's 3.3 ohms. Between those, 1.6 ohms. Between those, 3.5 ohms. Okay, so this one is connected to the midpoint, because from here to each of the other ones is 1.5 ohms. And between all the other ones is about 3.5 ohms. So this pin is connected to the middle one, so we don't want that pin. We're not interested in that pin, we're going to ignore it. So what I'm going to do is I'm going to put a black mark on that pin, just so we remember that we're ignoring it. So now we want to solder some wires onto these other 3 pins. So I've just cut off some breadboard wires here and have tinned the ends of them. Let's put a little bit of flux on these pins. Let's just get a fresh bit of solder on them. Okay, and we just want to get these pins stuck onto them if we can. Okay, that looks like it will do. Now we're going to get 3 phases of AC current out of these wires. So what we want to do is rectify it. So let's go into a breadboard with this. We're going to use these diodes. These particular ones are Schottky diodes. That's the model number. Most diodes will work for this though. Schottky diodes are good because they don't lose a lot of voltage. This is not going to make a whole lot of voltage. And the idea of diodes is that the current can only flow one way through them. It can't flow back the other way. So they're like a one-way valve. So we're going to need 6 of these. So each of these pins will have an AC voltage on it, swinging from positive to negative. On the positive half of its cycle, it will push current down through these ones, and on the negative half of its cycle, it will pull current down through these ones. So let's actually just solder the ends of these together. I think that's probably the easiest solution here. Okay, it's not pretty, but it should work. Now the thing about brushless motors is, and all of these kind of small motors, generally they're designed in a way that they take a small voltage and they spin really fast. So in order to get a decent voltage out of them, you actually have to spin them really fast. So we need to, if you're going to use these as generators, you need some way of spinning it really fast. So I've designed a little Pelton wheel turbine for this and 3D printed it. It's come out like this. The idea is we can stick that on there like that and then blow it with a straw. So let's try that. So that's decent. We can get a couple of volts out of it. I haven't actually stuck that down. I should probably stick that down with something. So yeah, that's it really. Little brushless DC motor that can easily be turned into a little generator, an actuator arm, and some hefty neodymium magnets. So all in all, plenty of little bits and bobs that you can use for maker projects. So yeah, hope you got something out of the video. Hope you enjoyed it. If you did, please leave a comment and like the video. Till next time, peace out.